Number 28, integral from 0 to infinity, x cubed e to negative x dx. This is improper because this upper limit is infinite. There's no domain restriction on the function, so we're okay in that aspect, okay? We can directly evaluate this integral. This is an integration by parts. Hopefully you recognize that. You could likely do a comparison test as well, but I will point out that you cannot compare with just e to the negative x. You might remember that the integral from 0 to infinity of e to negative x dx converges, but our function's bigger. So you can't use the direct comparison test to argue that if something smaller converges, something bigger must converge as well. That doesn't always happen. Okay? So that specific comparison of e to negative x dx won't work. Direct comparison. Maybe if you know the limit comparison or what people call the asymptotic comparison, whatever that business is, you might be able to do that. But as I've said in previous videos, if you're following along sequentially, or if you just happen to watch those videos, most students don't learn about that in the improper integral section, so I'm not going to cover that. All right? So let's just evaluate this directly by integration by parts. I'm doing the tabular method here. If you're not familiar with this, I'm sure there's other videos up on YouTube you can reference. I probably did this in my crash course in integration by parts video as well, so you can check that out as well. But anyway, so I picked my u to be x cubed, dv is whatever's left, e to negative x, and I differentiate this all the way to 0. I integrate this just as many times. We start with plus and we alternate side. We go across and diagonally down, across, diagonally down. Okay, that's actually the crash course right there. Even more crash course. Okay, so if we find the antiderivative, first of all, it's right here. Or I guess I did 2 steps in one. I did the antiderivative and fundamental theorem calculus. Okay, so this is a limit notation as well for the improper integral. We got to evaluate this limit. Okay, so I rewrote this as this negative exponent I rewrote in the denominator. Okay, we can evaluate this limit. And by the way, this 6 is the 6 came from there. Okay, okay. So what was I saying? To evaluate this limit, you could do L'Hopital's rule. You would have to do it like 3 or 4 times, if I'm not mistaken. Or you can just have the conceptual understanding that this exponential function goes so much faster than this polynomial ever can. So the limit would be 0 for this guy, but there's still the 6 out in front. So 6 minus 0 is 6. So we actually found exactly what this integral converges to, 6. Okay, so once again, this is one way to solve it. You can probably do a comparison test, as I was saying earlier, but you cannot make the direct comparison with e to negative x. We'll not be using the direct comparison test properly. So be careful if you do a comparison test.